Hi everyone, welcome to my channel. My name is Prativa. This is the continuation of the lesson Factorization, exercise 14.2 of NCERT Class 8 Mathematics. If you like my video, please subscribe and support me and like the content. So let's begin without wasting any time. So to solve exercise 14.2, we need to memorize the basic identities. Here I have listed down 5 identities. So what is an identity? An identity is an algebraic identity, is an equality that holds for any values of its variable. It must be true. Whatever value you assign to that entity, it must give us the value, regardless of the value, whatever value is assigned to it. So if we see the first identity, x square plus a plus b whole square, a plus b into x plus ab is equals to, the resultant is x plus a and x plus b. Second is a plus b whole square is equals to a square plus 2ab plus b square. A minus b whole square is equals to a square minus 2ab plus b square. A square minus b square is equals to a plus b into a minus b. Xy to the power m is equals to x to the power m into y to the power m. Now we'll see some basic examples on this identity before going to the exercise. So for the first identity, which is x square plus a plus b into x plus ab, gives us the result as x plus a and x plus b. So suppose this is the question, a square plus 2a, 12a plus 36. So how can we break 12a? We can break 12a as 6 plus 6, which gives us 12. Okay. So now we can write it down as a square plus 6a plus 6a plus 36. Next we can write it down as, we take a common from both these identities, which give us a plus 6, plus we take 6 common from here and a plus 6. So a plus 6 and a plus 6. So if we see from here, the identity x value is 6 or x value is equals to 6, because a and b here is 6 itself. Okay. Next let's solve identity number 2, which is a plus b whole square is equals to a square plus 2ab plus b square. So suppose this is our a and this is our b. So for p, according to the formula, first a needs to be expanded. So a will be a square. So 4p will be 4p square. Plus, I want you to write down the third one before writing the second entity. B square. B is 5q. So 5q whole square. Now how do we write 2ab? 2 at the front, a and b. So 4p into, this dot are the symbols of into 5q. Okay. And when we expand it, 4 square is 16, p square is p square. So whatever the entity, whatever the numbers or the expression or the alphabets, whatever is there in the bracket, we need to solve everything. Next, 2 into 4 into 5. 2 into 4 is 8, 8 into 5 is 40, p into q give the result of pq. Next, 5 square is 25, q into square is q square. So this is the answer. The next identity is similar to the second identity, which is here plus is there, here minus is there, and its resultant is a square minus 2ab plus b square. The basic symbol is, only difference is minus over here instead of plus, the before identity. So let's suppose take an example of 3a minus 2b whole square. How are we going to write this? Similarly, this is our a and this is our b according to the formula. So 3a whole square plus 2b whole square with a minus formula 2 into a into b. Okay, 3a into 2b. So now we expand it. 3 square is 9, a into square is a square minus 6, 2 3 ja 6, 6 into 2 is 12 and ab plus 2 square ja 4 and b into square is b square. So this is the answer. Next we come to the fourth identity, which is a square minus b square is equals to a plus b, a minus b. So this is our a and this is our b. Okay, so what is going to be our a then? A is going to be, what is 9a square? If this is a square, then 3a will be our a, right? Because when we square 3a, then we get 3 into square is 9 and a into square is a square, right? So a is going to be 3a, okay, and b is going to be similarly 2b. So how do we write the expression? 3a plus 2b, and similarly the same one with a negative symbol. Okay, so we study this as a square minus b square is equals to a plus b into a minus b. This is 2b. Okay, and for the last one, the fifth expression, we read it as xy to the power m is equals to x to the power m and y to the power m. For example, if we take it as, suppose 5b to the power m, so it is going to be 5 to the power m individually. This will apply on 5 and this will apply on b also with a dot, which is multiplication to the power b. So this is the answer. So I am sure now you got the brief understanding of how to solve the identities. Now straight away we'll move into the exercise 14.2. So now the first one, the first question is factorize the following expression. Okay, so here you can see the question is a square plus 8a plus 16. So how we can break it? We can break it as a square plus, we can break this one as 4 plus 4 into a, which is actually 8a plus 4 into 4. Okay, so now we are using identity number 1, which is x square plus a plus bx plus ab is equals to x plus a into x plus b. So what do we find here? Here we find that x is equals to a. Okay, so our x is nothing but x is a here. You see, x is a. Okay, and what is the value of a? A turns out to be 4. And what is b? B is also 4. So how did we find that a is 4? So you are just comparing. If you compare this one, okay, so x is a and a. If you compare this a and b, a is 4 and b is 4 and b is equals to 4 by comparing. So now what is the resultant? The resultant is x plus n, x plus b. So the resultant will be a square plus 8a plus 16 is equals to x plus a, which is a plus 4, and x plus b, which is a plus 4, and these two are same, so a plus 4 whole square. Okay, so this is how we are solving the first question. So the second part of question number 1 is p square minus 10p plus 25. Okay, so how are we going to solve this? We are going to solve this using the same method applied. So here what is our A? A is our P. Okay, A is our P. How can we break this expression? We can break this expression as P square minus 5P. Okay, 5. Okay, there is a minus symbol, so minus of, we take 5P, and again we consider 5 letter, minus of 5 plus P. Okay, so 10P can be basically written as, this is 10, minus 5 is minus 10, and P at the end, plus this can be written as minus 5 and minus 5. Okay, so now next you use the similar identity and we get the answer as, here A, our A is P, and the value of our X is P. A is equals to minus 5 and B is equals to minus 5. Okay, so what is the resultant? So P square minus 10P plus 25 is equals to X plus A, which is P minus 5, and P minus 5, which is equals to P minus 5 whole square, because our X is this plus A is minus 5 and X minus X plus B. X is P and B is minus 5. Okay, next we come to sum number 4. Here we are using the second identity, which is A square plus 2AB plus B square is equals to A plus B whole square. We are going to use this one. So 7 is 49 is the square of 7, and y is the square of y square. So this is our A square, plus 36. What is this? What number is the square? 36, 6, and z is z. So we squared this one as well. Now 2 into, formula says A into B, so 7y into B is our 6z. So it is going to give us the square, which is 7y plus 6 of z whole square. Okay, so this is the answer. Next we move on to the fifth part of question number 1, which is 4x square minus 8x plus 4. So you see which formula does it replicate. Doesn't it replicates A square minus 2AB plus B square? You see minus symbol is there, and what is the expansion? It is the expansion of A minus B whole square. So we need to put it as this formula. So how are we going to do this? 2x whole square, which is our A, plus 2 square with a minus symbol, 2 into 2x, which is A, n into 2. This is A and B. This is B and A. Okay, so next 2x A minus B, which is 2 whole square. So this is our answer. Next we move on to part 7. Okay, so in part 7 also, first of all, you see here it is a formula L plus M whole square, which is A plus B whole square. Already it is given in the shape of a formula, but with the different alphabets. So how we do expand it? A square plus 2AB plus B square. So similarly L square plus 2 into L into M plus M square. So we expanded this and we wrote the same 4LM. Okay, so you can put L square plus M square, C plus C. I am just rearranging it. Okay, so plus 2LM and minus 4LM, which brings us to minus 2LM. Okay, so after coming to this is actually the formula of L minus 2AB, A square plus B square minus 2AB, which is a minus b whole square. Okay, so in this case a is L and m is b, so it is going to be L minus m whole square. So this is our answer. Next, if we come to this sum, it's a sum number 8 of question number 1. So here you see the formula which we'll use is a plus b whole square, okay, is equals to a square plus 2ab plus b square. Okay, now after this you see, now how are we going to solve this? This is actually a square to the power square is a to the power 4 plus b square to the power square is b to the power 4 plus 2 into, this is our a, this is our b. So 2 into ab is nothing but, 2 into ab is nothing but, this is our a and this is our b. So a square is our a and b square is our b. So how are we going to write this finally? As a square plus b square, which is a plus b and whole square. So our answer is a square plus b square whole square. Now we come to question number 2 of 14.2 exercise. So what does it states? It is question number 1 is 4p square minus 9q square. So which formula is it? We are using the formula here, a square minus b square is equals to a plus b and a minus b. Okay, so here first of all, what will be the square? This is 2p whole square. 2p whole square is equals to 4p square minus 3q whole square is equals to our, we are going to write down in simplest form as this. So now this is in this form, so we can write it as a plus b as 2p plus 3q 2p minus 3q. So this is our answer. And one thing to notice, whenever you expand this identity specifically, you write, whether you write, someone write 2p minus 3q at the start, or this at the end, or this at the start, or the minus bracket at the end, doesn't matter. If the answer is this, that is fine. Next we come to question number 2, sum number 2. So here we see 63a square minus 112b square. Okay, so first of all we need to find out if there is a big number, take a smaller number which can divide both of them. Okay, in this case suppose 7 is taken, so 7 9 just 63, so 9a square minus 112, how many times it divides? It divides by the time 7 8 9 by 16, so 16b square. Okay, so we keep 7 at the and we start with the second bracket. So 9a square is actually 3a whole square minus 4b whole square and the braces. So 7 3a plus 4b and 3a minus 4b. Here we have applied this formula because it is in the form of a square minus b square. So this is our answer. Okay, so whatever, if there is a higher number, so we take out the common factor, common number which divides it, and we put it in the front. Okay, so the next one is 16x to the power 5. Okay, it is 16x to the power 5 minus 114x square. Okay, which is question number 4 of exercise 14.2. So here how are we going to solve it? First of all, what is common? You see here, this number can be divided by 16. So 16 is common and x square is common. So what will be left? This will be left as sorry, in the question this is x cube. So x cube is common, so x to the power square will be left here, okay, minus 9 will be left here. So 16x cube, similarly to the previous question, it is going to x square minus 3 whole square. So it is going to be 16x cube, x plus 3 and x minus 3. So our answer will be 16x cube, x plus 3 and x minus 3. Okay, so this is going to be the answer. So you see this is also the form of a square minus b square. Okay, and also yeah, so how are we going to do this sum? This is question number 2 part 4. Okay, so in question number 2 part 4, you see we are going to use the a square minus b square identity. Okay, so if we apply this one, a square minus b square, so consider this as a and this as b. Okay, so L plus m a plus b whole square is equals to a plus b. So a plus b is equals to this plus L minus m, this is our a plus b, and a minus b is equals to L plus m minus of L minus m. Okay, so it is going to be L plus m plus L minus m into L plus m minus L, and minus minus is plus m. So it is going to be 2L. These and this got cancelled because plus m and minus m gets cancelled, and here plus L and minus L get cancelled. So 2L into m square. Okay, sorry, it is going to be 2m, not squared. Okay, so what is going to be answer? This is an into symbol, so this is going to be 4lm. This is the answer. So the next question is question number 7. So in question number 7, how are we going to solve it? This, consider this as a and this as b. So actually we need to put it in a plus b whole square format. So now how are we going to do this? This is actually x square plus y square plus minus 2 into x into y, and which is the formula of a minus b whole square, which is x minus y whole square, minus z square, we put it this way, and minus z square. So now this is, consider this as a square and b square. Okay, so it is going to be a plus z, a plus b, and a minus z, a minus b. Okay, because a square minus b square is equals to a plus b into a minus b. Okay, so next if we expand it, x minus y plus z and x minus y and minus z. So this is our answer. Next is we need to factorize this. So how are we going to factorize this? If we need to find the common here. So what is common? X is common in both. So we take x, a, and one more x is left because it is square, and plus b. So this is our answer. Similarly, what is common here? 2 is common. You see, x is common. See, x cube is there. We're going to take the smallest one, which is x to the power 1. X to the power 1. So x is common. No y, so we cannot take y. No z. So 2x is common. So here what will be left? If 2x is gone after x cube, x square will be left. Plus what will be left here? 2y square. And what will be left over here? Sorry, 2 won't be left because 2 is already taken in common. So x is gone, only y square will be there. Next, z square will be there. Okay, so this is going to be our answer, right? Next, let's come to question number 3, part 4. So in part 4, you see this is the number. So what is common over here? The common digit is m square. We'll see first two and last two, and a plus b. Okay. Next, it is going to be, see, b is here and a is here. So if we want this to be common, first we need to arrange it. B square plus an square plus bn square. Okay, we have just put it forward and this one backward. So now relating to this, what is forward, what is common here? N square. So a plus b. Okay, so next a plus b, this both common will be taken here, and whatever is left we'll put it here, m square plus n square. Okay, so this is going to be our answer of question number 3, part 4. Done. Next is question number 4, and the question we are solving is part 1, which is a to the power 4 minus b to the power 4. Okay, so you see a relation between a square minus b square here. So we are using a square minus b square is equals to a plus b and a minus b. This is very helpful formula, so memorize it. So a square minus b to the power square minus whole square. Okay, at the first stage we can write it this way, and again we can write it as a plus b, a minus b. So a square plus b square, a square minus b square. So again you see this is a square plus b square formula here. Okay, so we are just going to write it now this way. So the first one is going to be this way because there is no formula for a square plus b square. So a plus b and a minus b. Okay, so this is going to be our answer. Next we come to p to the power 4 minus, this is very similar to the first one, p square whole square minus 9 whole square, right? 81 is the square of 9. Now p square plus 9 and p square minus 9. Again see, this can be broken down again in this formula, so we can apply the same formula twice in an expression. So leave this can be broken down as p square minus 3 is 9 square. So now p square plus q can be kept this way, and this is p plus 3, p minus 3, which is a plus b, a minus b. So this is the answer. If you are liking whatever I am teaching, if you are understanding, please subscribe to my channel. Next, a to the power 4, which is question number 4, part 5. A to the power 4 minus 2a square b square plus 4b square. So here we are going to again use which formula? We see minus and pluses, so it is going to be a square minus 2ab plus b square is equals to a plus b, a minus b whole square. Okay, so a square whole square plus b square whole square minus 2 into a square into b square, a into b. Okay, so it is going to be a to the power square a minus whole square. Okay, so how can we break it? So we can break it the inner one as a plus b minus a into b and a minus b, because this is the formula of a square minus b square, right? And this is the whole square. So it is going to be a plus b whole square and a minus b whole square. So this is our answer. Next you see question number 5 of factorization. So the first one which we are going to solve is p square plus 6p plus 8. So I'll tell you a shortcut how do we see this number. Okay, so we break it in such a way so that the addition is 6 and the multiplication is 8. P square plus 4p plus 2p, isn't it 6p, plus 8. So 4 into 2 is 8 and 4 plus 2 is 6. This is how it is going to be. So next what we can do, we can apply common in first 2, which is p plus 4, and again apply 2 is common, then it brings to p plus 4. So it is going to be p plus 4, and whatever is left we write it in another bracket as p plus 2. So this is going to be our answer. So for the second one, which is question number 5 part 2, q square minus 10q plus 21. So how can we represent this one? We can represent as 7 3 7 21, right? So minus 3q, this is q, minus minus is minus, okay, minus minus actually a plus, and 10q, this brings to 10q plus 7 into 3 is 21. Okay, so we are just breaking it in simpler form. So what do we take common? Common is only q, so q minus 7, again minus, because the third entity is minus, we take minus, and 3 is common here, q, and minus plus is minus 7. So it is going to be q minus 7 and q minus 3. Okay, so this is going to be our answer. So I hope that you all like this video. Meet you all in the next session. Thanks for watching my video. Till then, stay safe and happy learning.